Corrosion is the attack on the surface of a material by the environment. The corrosion of a metal involves microscopic electric currents on a film of moisture on the surface. The corrosion is electrochemical in nature. When a metal corrodes, atoms are lost from its surface, leaving behind an equivalent number of electrons in the body of the metal. This is called an anodic reaction, and the surface where it takes place is termed an anode. Meanwhile, oxidizing agents will react with the metal surface to remove the electrons left behind. This cathodic reaction takes place at the surface called a cathode. Electric potential, temperature, the acidity or alkalinity of the electrolyte all have an effect on what sort of corrosion takes place. Corrosion has been classified into 8 main types. 4 of these, intergranular, selective leaching, stress and erosion corrosion, are mainly the concern of industrial chemists and engineers. They occur in an industrial plant where high temperatures, powerful chemicals and mechanical stresses can and do wreak havoc. The other 4 concern us all. They're unsightly, expensive and often dangerous. General corrosion is uniform attack over a surface. The anodic and cathodic areas are evenly distributed. In ferrous metals, it is the most common form of rust. The patina on copper is another form of general corrosion. Galvanic corrosion, or dissimilar metal corrosion, is the result of 2 metals, one more active than the other, being in contact. When they're connected, the more active metal becomes the anode and the other the cathode. The anode then corrodes rapidly, leaving the cathode unscathed. The likelihood of galvanic corrosion can be predicted from the galvanic series. Based on experience, this list applies to metals and seawater. Generally, the further apart the 2 metals, the worse the more active one will corrode. The so-called noble metals are virtually uncorrodable. Active metals such as sodium and magnesium react with air and water very rapidly. Stray current corrosion is a special case of galvanic corrosion. A direct current source causes corrosion at points where current leaves a structure. These become anodes and protect those areas where the current re-enters. Crevice corrosion concentrates in narrow fissures where oxygen access is poor. This makes for a large passive cathodic area and a small anode. Insidious attack in the crevice. Some metals and alloys, such as aluminium and stainless steel, have what is known as passive protection. A thin layer of oxide, a film so thin as to be invisible, about 10 millionths of a centimetre, forms on contact with the air and prevents further attack. But this layer can be breached, and often is, particularly by chlorides, such as sea salt. Pitting corrosion is the result. Here, the pits have penetrated deeply into the steel plate, weakening the tank this came from and causing complete failure. The anodic reaction is localized and intense, while the cathodic reaction occurs over the surrounding surface, which remains uncorroded. This aluminium teapot was left by the seashore for some time. You can see how deep the pits are from these growths coming out of them. The pits have really wormed their way in. Those are the 8 types of corrosion that metals are liable to, although there are other types, no less expensive and dangerous, but less common. But that's not the whole story. Plastics corrode, wood corrodes, concrete corrodes. But our most usual corrosion problems occur in metals. Metals in contact with metals, and metals in contact with moisture. We still have a lot of research to do. We are still ignorant of many aspects of corrosion and how to deal with it. But what we do know is increasing all the time, and it's becoming more important as we extend our use of materials further and further.